Hello, hello. Are we live? Looks like my video is live. Is my audio working? Yeah? Yeah, looks like that's working. All right. Do I want to keep that tab open? I guess not. Can I see the chat anywhere? Yeah, okay. I think I have to have Firefox open in my other monitor. Bear with me for a second while I get the stream up and running. It's been a while since I've done this. And welcome to the advent of code. Am I muted? Okay, yeah, I'm muted, so I won't have any echoing audio. Yeah, welcome to the advent of code. I have not taken a look at this yet. I am going to be doing the advent of code this year in Syntran. That's my interpreted programming language with an interpreter written in Fortran. So before we take a look at the actual advent of code problem today, let's dive into what is syntran. Let me put this behind my webcam so that I can't see what you can't see. Okay, yeah, so what the hell is syntran? It's an interpreted programming language. If it ever starts up. Apparently streaming is bogging down my system. Come on, I have an alias for this. Just have to resource bash rc. There we go, there's syntran. So it's an interpreted programming language. You get a prompt right there, and then you can type things in. You can type in math. 1 plus 2 is 3. That's all well and good. You can do multiplication, of course, as you would hope. The order of operations is correct, so we multiply 2 by 3 before we add 1. Maybe I should start with hello world before I do math. So hello world, you can just write a string, and that will get implicitly printed. Everything that you type into this REPL gets evaluated and echoed back as the answer. So when I type in a string, the answer is just that string again. So it's the same as if I type the number 1, that gets echoed, or a mathematical expression that gets evaluated gets echoed, like the answer is 2. So maybe you can argue that implicit printing of a string isn't hello world. So that's what the print line function is for, if you don't want to just rely on implicit printing. So we can do that, and it prints hello world again. Let me split my screen. I have to think very hard about the tmux shortcuts. Let me split that again so that, there we go. Now one of these panes is useless because it's all behind my webcam. Instead of printing to the console, let's print to a file. So you can open a file. So let me make a file called twitch.txt. There's no file there yet because we haven't written it yet. So what we have to do is open it. Let f equals open twitch.txt, and then we can print to that. Except instead of printing to the console, we're writing to a file. So that's write line, hello Twitch. Yeah, thank you. I have to tell it which file to write to. That error message was very helpful. So write to the file F that we just opened. And then after we're done with that file, we have to close it. So now if I look at what I just wrote again, now there's a file that exists. And if we look at what's inside that file, there it is. That's probably sufficient for a hello world. And syntran is supposed to be an array-oriented programming language. So you're not just limited to scalars. Like where was multiplication? Come on, reverse incremental search. So you're not just limited to multiplication like this. With scalars, you can have vectors as well. So we can have a vector like this. These are all the numbers from 1 to 10, not inclusive of the upper bound 10. So there we have 0 up to and including 9, but not 10. And you can also have matrices. So we could have something like an identity matrix. We're going to make this a 3 by 3 matrix, and I'm going to break it up on multiple lines. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And then since this is not just a vector, we have to tell it how big this matrix is, because most numbers have two different ways that you can factor it. Like you could have a 2 by 3 matrix or a 3 by 2 matrix. So you have to specify the size. This is a 3 by 3 matrix. And there's our rank 2 array. Yeah, syntran is designed to work with arrays like that. It's not really great at vector operations yet, so you can't really multiply a vector by a scalar like this. Remember, we defined this vector earlier. Unfortunately, that's not allowed yet. This is high up on my list of things to do. I want to like implement operators so that you can do scalar vector multiplication, matrix vector multiplication, and all kinds of things like that. But this is a work in progress. And all I'm hoping is that I can do a few days of the advent of code in syntran. I'll probably get to about day 5, and then there's probably going to be a problem that requires recursion or user-defined types or structs or something like that that syntran doesn't have yet, and then I'm going to be stuck. So I think that's enough of an introduction to syntran, and with that, let's dive into the advent of code. The first thing I want to do is make a new GitHub repository. So let me add a new repository, and this is going to be AOC syntran. I already have another another AOC repository that I did a lot of the 2022 problems in, and I did those in Fortran. Also, I learned my mistake because I put 2022 in the repository name, and then I started doing problems from other years, so now the repository name doesn't make sense, but I don't really want to change the name of an existing repository because then I'll have a bunch of broken links all over all of my websites. So I'm not going to put 2023 in this year's repository, but I am going to put the name of the language in there to differentiate it from my Fortran repository. So yeah, this is going to be AOC syntran, and this is for the advent of code in syntran. It's going to start out as 2023, and then who knows, maybe I'll do 2024 in this next year. Let's give that John a BSD3. And yeah, do I have something hidden behind? Yeah, there's the create repository button, hidden behind my webcam. Okay, so this exists now, and I need to clone it locally. Come on. I clicked this SSH, copy that, and then I want to clone that right here. And then cd, not into my 2022 repo, but into the new syntran repo. And all we have are a license and a README. So let's divide up these directories by years. Let's make one for this year. And then I could have done this in one shot, but yeah, let's do one for today. Yeah, that's it. Then I want to cd or push d into that. And this is an empty folder. Yeah, so like I showed you, I'm running syntran just by typing sy. That's like a custom alias there. So if you're following along and you want to play with this language, you can run syntran by typing syntran, but you'll obviously need to have the interpreter. So how do you get that? You have to build that from source if you want to run this, and the way that you do that, this is in a separate repository. Maybe I'll include this as a submodule to this AOC repository. I haven't really decided yet. But this is the repository where syntran is implemented. So this is the interpreter for syntran. If you want to build this yourself, you have to clone this repository and then take a look at the README. The README tells you how to build this thing. So there's a build script. You just run the build script. That build script runs cmake, and then you get this interpreter in a build folder. That interpreter's name is syntran. And if you want to, you can copy this to some folder that's in your path. Like there's an install script which will update my syntran interpreter that I have system-wide. So for me locally, which syntran, I have that in my home Jeff bin folder. And then I also have an alias in my bash rc file, so that instead of typing out syntran, which is like, what is that, 7 letters long? That's a little bit too much to type. I can just type sy, and that's a quick way for me to start the interpreter. Where was hello world? Not that one. Yeah, so that's the interpreter. Yeah, I think it's time to dive in, almost time to dive into the advent of code. I want to start out with like a template. Yeah, maybe I'll write this at the same time as I'm looking at the problem for day 1. Let's call our file main.syntran. And this is going to have our main program. And then we're going to have part 1. If you've never done advent of code before, every day has 2 parts. There's a part 1 and a part 2. So I'm going to have separate functions for each part. But at first I'll only have part 1, and then later I'll implement part 2, because you can't unlock part 2 until after you finish part 1. So let's have a stub for the main function. Let's just echo some stuff so that we know it's running. Let's just get a blank line for readability, because that's the way I like to do things. And then let's have another line at the end so that we know it finishes, instead of like crashing abruptly or ending prematurely for whatever reason. Because this language is a work in progress, there's a very good chance that you will see this crash and you will see me find bugs as I'm working through these AOC problems. Hopefully not on day 1. I hope I can get through day 1 without doing anything embarrassing. But you will see some bugs eventually. Yeah, let's see if that runs. So if you just run syntran, you get this interactive interpreter, and you can like test things out on the fly and see the results as you're writing code. But if you have a file, which now we have main.syntran, you can run that by giving that as a command line argument to syntran, and then it prints that stuff that we just typed, starting AOC main, and then, oh, I should be consistent, starting ended with ing, so then let's have ending AOC main. There we go, that's a little bit better. While I'm at it, there are a couple other arguments for syntran. So you can do -h to show all of this. There's a version argument, which will just print this and then stop. And then if you have syntax errors, like let me show you a syntax error. Like let's say I forget to close my function bracket. That should be an error. Yeah, so that will say, first of all, undefined function, because I'm trying to call main before I closed that bracket to finish implementing main. And then there's an end of file token before we got that closing bracket. So yeah, you can get a bunch of error messages. This one only had 2. Let's try, what can I do? I think if I do this, I'll get a whole bunch of errors if I delete that parenthesis. Yeah, so now I should have had a parenthesis right there, but I deleted that just to demo the error message. So now it hits this bracket, and that's unexpected. So we get an unexpected token at line 3. the error message tells you the line of code where the error is. And it's thinking maybe there could have been an identifier there could have been a colon, there could have been some other identifier. So what we have here are cascading error messages, and it stops after the first 4 and it omits the next 14. And that's what the fmax errors argument is for. GCC has an argument like this. I think its name, maybe it only has 1 dash or something, but I think if you have an argument that's more than 1 letter long, it should start with 2 dashes. At least that's how most programs work. So I named mine slightly differently than the GCC error message. But we can, if you want to see all 14 or all 18 actually error messages, then you can set that to like 0 or a negative number. And now we get like a whole lot more error message as opposed to like just doing the first 4 and then stopping. Yeah, so those are the arguments to syntran. So I have main, and then I think I want to have a part1 function, and I want to have all of these return integers. So I want to return 0 at the end. Yeah, it's kind of arbitrary, but let's return 0, why not? And then I want to have a part1 function, which returns an integer. This is going to be like a template file, and once I get a stub function for part1 and like definitions of the input files and the test inputs, that's going to be a template that I'm going to copy for every other day of the advent of code. So when I start day 2, instead of like writing all of this from scratch, I'm just going to copy this from day 1, but not like all of day 1's implementation, just the stubs like this. So this is going to become a template, so it's worth spending a little bit of time on it. So our answer is going to be sum. Usually the advent of code problems, it's some sort of sum, like you start with something and then you add up a bunch of stuff. So we're going to name our answer sum, and then we're going to call part1 from here. Yeah, we don't have to assign the output to anything. We can just do it like this to call part1. And there's our answer at the end. So it prints 0 for part1, and then it prints 0 from main again. Maybe I want main to be void. So to have a void function in syntran, you just get rid of that stuff on the right side of the main function declaration. So now part1 prints 0, and then we still get 0 again. Did I save that? Okay, whatever. I think that's going to be how it is. Then we're also going to have input files with the advent of code. So they'll give us a test input, and I think at this point we can actually look at the problem. I haven't looked at this yet. This will be the first time I'm looking at the problem for this year. So let's go ahead and click on day 1. I'm not going to read through this. I'm going to try to quickly skim it and just do this as fast as possible so that you don't have to sit here and watch me read. Oh man, we're going to have to do a lot of string parsing. I was hoping this wouldn't happen until day 2. I was hoping we could get like just numbers without having like unrelated text mixed in with the numbers. And Fortran doesn't, sorry, not Fortran, syntran doesn't really have intrinsics built in to deal with these things. So we're going to have to implement a lot of it ourselves right here. So be it. I was going to have to do this eventually anyway. So we're gonna have to read this line, ignore the letters, and just get the first digit and the last digit. So that's 1 and 2, or 12, and then the second line has a 3, and an 8, so that's 38, and then similarly for every line. Yeah, and like I said, most of these problems, the answer is some kind of sum, so we have to sum up all of these numbers, all 4 of these numbers, and then the answer for the test input here is 142. Let me copy that and save it. So we're going to have a file called testinput.txt. And in here, I'm just going to paste what I just copied. That didn't work. Right click, paste. There we go. I'm dealing with a lot of layers. I have Windows, and I'm running Ubuntu inside Windows and tmux inside of Ubuntu. So like copying and pasting is like the hardest thing that I do on a regular basis, and I never know which keyboard shortcut or mouse action will actually paste into the thing that I'm in. Did you make your own compiler? I made my own interpreter. When I started this language, I wasn't really sure where I wanted to go. I had an idea of maybe making a compiler, but that's kind of difficult, so I just left it at an interpreter, and that's where I am. By the way, welcome to the stream, Dink. It's good to see you again. So this is my test input, and then I want to get the real input too. So let's save that as understandable. I haven't seen you live in a while. Maybe I just missed it a couple times. Yeah, I was working on this back in April, and then I took a break for a while. So I didn't work on this language at all for many months. And then about 3 weeks ago, I was like, oh, Advent of Code is coming up. I think I'll do that in Fortran again. And then I remembered, like, wait a minute, I had my own language. So very hectically, I had to hack file input into my language because I didn't have any way of reading files. And that's sort of a critical thing in Advent of Code. You need to be able to read the test input, and then you need to be able to read the actual input. And it's good to have like a quick way to switch between them. So I think I have enough features in this language that I can do about 5 days or so of Advent of Code before I get stuck. All right, we should have both inputs now. Yeah, we have the test now we have the test input and then the real input, which let's take a look at that, by the way. It is 1,000 lines, and basically every line only has no, never mind. So some lines have 3 digits. This has like 9, 4, and 3. But as I understand the prompt, is this one? Okay, yeah, the test input says 1, 2, 3, 4, and 5, but we just need the first and the last digit. So 1 and 5 in this case. And then if any line has more than 2 digits, we just ignore all of the ones in the middle. Sounds cool. Probably a good way to test ergonomics for essential stuff, at least. Yeah, I was thinking that Advent of Code would be like a great thing to test an in-development programming language. I mean, this is just a toy language. This isn't going to be anything serious that anybody uses for real. But I hope it can solve stuff like Advent of Code problems. And that's what we're going to find out. I did do a little bit of practice. I went back to the 2020 problems, and I solved like the first 3 days in Syntran, so hopefully this year isn't like significantly harder than the other years. Yeah, we have the files, now we need to read those. So let's put those names in a vector. We can have a vector of strings in Syntran. So the first thing is going to be the test input. And then the second one is going to be the actual input. And that's our array of files. And then the file singular is going to be selected from one of the members of that that vector. So file, these are just global variables, right? These are like outside of all of the functions. There's a function, but these things are outside of the functions, so these are global variables. The scoping and the blocks in syntran, they kind of work similar to C. So in C, you would also have global variables out here. So at first, we're going to work with the test input. I think I want to have a variable here. So ifile. And then when we work with the test input, we're going to set this to 0, and it's going to select this part of the array. And then when we want to switch to the real input, all I have to do is change this 0 to a 1, and then we'll get like the second file instead. And this is going to be the file that we load. Let's say file name, not files. Because then like the file object is different from the file name. So that's how that's going to work. And then part 1 needs to read this file line by line. So we're going to need a loop for that. So we open it, and then we need to check whether at the end of the file or not. So syntran has a function called EOF to check if you're at the end of a file. How do I want to do this? I want to make sure that I don't process the last line twice. So I think I want to read a line first. Read line from F. So we're going to read a line first, and then we're going to start a loop. So while not EOF, I already typed that. While not EOF, and this is going to be our main loop. So I just want to print this. And then at the end of the loop, I'm going to read the next line. So str equals, it's the same thing that we had outside of the loop. Now we have it pasted at the end of the loop too. But I think this should be correct so that I only process the last line once. Yeah, and then if we try to read past the final line, EOF will be true, and then we'll exit the loop. So let's test that this reads everything correctly. Oh, that's the real input. Yeah, let's do the test input first. Yeah, so there are 4 lines there. Is that right? Yeah, we have 4 lines in the test input, and we read each of those lines exactly once. So I think this looks okay. And this is basically our template. So for every day in the advent of code, there's going to be a test input and a real input, and then there's going to be a part 1 and a part 2. Let me put in a stub call for part 2, but just comment that out because we're not implementing it yet. And then every day in the advent of code, we're going to read the file line by line. So we're going to do it in a loop like this, and we're probably going to add up some sum. So this is going to be the template that I copy every day when I start advent of code. So I think I want to back this up somewhere else in my repository. And let's just put that in the top level and call it template.syntran. And then when I make day 2, I'm going to make a separate folder for day 2. Then I'm just going to copy that template and start from there instead of writing all this stuff from scratch every day. So that should speed up my development a little bit in the coming days. Yeah, I think that's it. Let me just double check one more time that this actually runs, and then I didn't like accidentally edit anything before I copied that template. Yeah, I think that's good. Now I think we're ready to solve day 1. I don't really need a general number parser. I just need to find the first digit and the last digit. There's this function in Fortran called scan. I think other languages probably have something that's similar. Or maybe not, I don't know. I know Fortran better than most other languages, so what scan does is it scans a string to find any character that's in a set of characters, and it can either scan from the beginning to the end, or if you set this thing to true or false, it will scan from the end towards the beginning. So this is exactly what we need for AOC day one. We want to scan from the beginning and find the first digit, and then we want to scan from the end and find the last digit. Yeah, so let's implement this in syntran and model it after this Fortran function. So, yeah, let's just implement it in here to start. I had to think very hard about the key bindings to do that all in one Vim keystroke. Let's have a function to scan. I think I want to have two separate functions. So Fortran has this logical argument and it's optional. So if you call scan with just the first two arguments, it scans from the front to the end by default. But if you add this optional argument and set it to false, no, if you set it to true, then it scans from the end towards the beginning. But I don't have optional arguments in syntran yet, so instead of having one function with an optional argument here, I'm just going to have two separate functions to scan in both directions. There's going to be scan and scan back. So this one will always scan from the front. It will take a string argument, and then it will have a second argument for a set. And that's also a string, and this will return an index. It will tell me like which character index in the string is the first digit. But it's going to be general, so this scan function could be used for more than just digits, but then in part one, I need to find digits, so I'm going to call something like let I equals scan string all digits. I think that's all of them. So the first is going to be the string at that index. Yeah, I think that should work. Now we have to implement this function. So, at the end, we're going to return I. This is something that I haven't really decided how I want syntran to work. I don't have an explicit return statement. It's just whatever the last line of your function is, that's the return value. So Rust works in a similar way, actually, but in Rust, you leave out that semicolon. So in Rust, you would return like this. In my language, you still have to have the semicolon, but it's the last line of the function that defines the return value. So we have an index, and then we want to keep track of whether we found a digit or not, although it's generalized, so it's not necessarily digits. So let found equals false, and we're going to loop until we find it, or until we get to the end of the string. So while not found and I is less than the length of the string, we're going to loop. At the end of the loop, we're going to increment to the next index, so I plus equals 1. And then we're going to check if we've found a digit or whatever string set we're looking for has been found. And for that, we need another nested loop. So while not found and j less than the length of set. The set is like the needle that we're looking for. So set is the needle and str underscore is the haystack. So we're looking for a needle in a haystack. So we're looking for some character in set that exists in str underscore. So j needs to be initialized. And again, at the end of this loop, we're going to increment j. And then found will be true if the string index I equals the set index j. And I think that's it. So this will scan from the front to the back. We're going to have to make another function later to scan in the other direction. It's going to be a similar idea, except we're going to set I to the length of the string at the beginning, and then we're going to decrement I instead of increment it in the loop. If you were smart, you could combine these into a single function as long as you haven't like a Boolean argument that tells you which direction to scan. But a little duplication is better than the wrong abstraction, so I'm just going to copy and paste this thing and then have a separate function. But let's see if this one works. So can we find the first digit of every line? So we should get 1, 3, 1, and 7 if this works correctly. 1, that did not work. Oh, so I think maybe it did work. No, it didn't work. 1, 4. Like, how did I get 4? 4 is not even in this string. Oh, I'm printing first. I'm off by 1. Okay. Yeah, so at the end of this loop, actually I find something. Okay, yeah, I forgot a few things. So I find something and then I increment I. But if I found something and then I have to undo this final increment. So the other case is that maybe we didn't find a digit at all. So that's not going to happen today. Like every one of these lines has at least one digit, so we're always going to find something. But for this general purpose scan function, the way that Fortran works is if you don't find anything, the result is 0. Well, Fortran uses 1-based indices. So like 0 is an invalid index. So if you get 0, you know scan found nothing. In my language, the indices are 0-based, like in C. So if I don't find anything, I want to return -1 instead of something that could be a valid index. So if found, we're going to want to return I -1. Why write it like that? Like, we don't have to assign it to I. And then if it's not found, we're going to return -1 because that's an invalid index. And then that should fix my off by 1 problem. So yeah, now we get 1, 3, 1, 7, and those are the first digits of each line. That's the forward scanner. What am I doing? I'm saving Vim in the console. Yeah, that's the forward scanner. Now we also need the backwards scanner to get the last digit in each line. So let's have another function. This is going to be called scan back. And we're going to scan in the other direction. And we just basically invert any line that refers to I. So instead of incrementing, we're going to decrement. And then if I don't find anything, I still want to return -1, but if I do find something, I have to add 1 instead of subtract. Yeah, so that's the first one, and then we want the last one. So scan back, and then the last digit. That should do it. Let's see if that works. So if this works, we should get 2, 8, 5, and 7. I is already declared. So syntran is a little bit like JavaScript. When you declare a new variable, you use the let keyword. But then if you want to refer to that variable again later or like reassign it to something else, you don't use let. So what did I say? We should get 2, 8, 5, and 7. I think that's right. Let me just take a look at AOC again. Yeah, so that final line, this is a little bit weird because the first digit is also the last digit. So on that line, the 2-digit number that they want you to sum up is 77. So I just wanted to verify that that was right and I wasn't just like ignoring a digit there. Yeah, so now we have to make the 2-digit number and then add all of these things up. I need more variables, or I do want to use let because I want to have j here. And then my 2-digit number is going to be, this is going to be a string, so digits is string I and string j. In syntran, use the plus to concatenate strings. So this just takes the digit here and the digit here and concatenates 2 single digits into a 2-digit number. And then the result is another string. This isn't really an integer yet. So let's just print that out so you can see what I'm talking about. Let's comment out the other things. Let's comment out the string printing too. Yeah, so we get 12, 38, 15, 77. I think that's right. I'm not even going to bother checking, but these are strings. We need to convert these to integers and then sum them up. So sum plus equals convert to integer these digits. That's not a function. Yeah. I renamed this recently. I used to call it I32, but now it's parse I32. 142, was that right? Yeah, 142 for the test input. Let's try the real input. So switch this 0 to a 1. Oh, come on. I don't know what I just did in tmux. Oh, okay. So it did crash. It only got to the 3rd line before it crashed. Let's print the string again. Is that right? Is that actually what the test, is that actually what the input is? 6 FF. Do I have like an off by 1 error? Oh, yeah, I think I do have an off by 1 error. So I either find the first digit or the last digit, but not both. So how did I do that? Let's see which one is wrong, because there's only 1 digit in this line again, and I don't know whether I found the first digit or the last digit. Yeah, so last is empty. Somehow my scan back function is wrong. So this should be greater than or equal to 0. It's those off by 1 errors. That's one of the 3. That's one of the 2 hard problems in computer science. By the way, the 2 hard problems in computer science are naming things, cache invalidation, and off by 1 errors. Okay, so I messed up this one too. How did I miss this? How did I mess this up? I got through like 52 lines before I crashed on this somehow. Like, how? I was hoping I could get through one day without any crashes or bugs. But yeah, Syntran doesn't really have any runtime error handling. So instead of like instead of a Syntran error message, you get a Fortran error message, and it gives me a line of code in the interpreter instead of like the line of Syntran code that I'm working in. Like I have 110 lines here, and then this is giving me an error at like line 6,000 whatever of the interpreter. So this is not helpful for me as a Syntran user. How do I not get this? Did I forget a number here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the digits. I don't know what's wrong here. If I was doing AOC in Fortran this year, I wouldn't have to implement this function myself. It would just be built into the language. So this would be very easy in Fortran, but yeah, in my own language, it's a little bit more difficult. What am I doing wrong? Let's check some of the other lines manually. 44, 11, 66, 79, 82, 78, 91. 91 is not correct. It should be 95. Oh. So one of the things about Syntran is there's no bounds checking. I don't want to start out at the length of the string. I want to start out the length of the string minus 1. There we go. Is that correct? Let's find out. Let's go. Part 1 is finished. That's the right answer. Let's go on to part 2. Oh my god. Day 1 is harder than I wanted it to be in Syntran. "13." Are they always spelled out? Oh god. This sucks. This is way more work than I wanted to do for day 1. If you look at 2020, which is what I did to warm up, 2020, they just give you numbers. You don't have to do any text processing, you just read the numbers. And this was so easy in Syntran. The only thing about 2020 is that you had to have vectors in your language. So like you needed to save this as a vector rather than just like reading one line of text at a time and then forgetting about the last line of text. Syntran is much better with vectors than it is with text processing. So I would have preferred to have a problem like 2020 day 1. but 2023 is slightly less trivial than that. So I need to have like all kinds of logic in here to try to like parse a number as text, and then also check if there's a digit instead. This is kind of annoying. Scan. What do I want? Yeah. So not only did I have to implement scan in syntran, now I have to implement index, which finds a substring within a string, which is technically different than what scan does. They sound similar, but what scan does is it finds any character in a set of characters. It's not really looking for a substring. But index works with a substring, so I have to implement this other Fortran function in syntran now. Because this is the way I like to work with strings. This is the way I'm used to dealing with things in Fortran, so I want syntran to have similar functions as Fortran. If you're used to some other language, it might not have functions exactly like this, so you probably have some other way of working with strings, but this is what I'm used to. So now I have to go ahead and implement this too. Yep. This is annoying. It's also annoying that we have a third input now. So we have like test input 2, test input 2.txt, and I have to save that. So that's going to be test input 2. Now we have to get this thing working. I have to feed my cat at some point, so I might need to take a short break. Not just yet. This is good though, because I'm like building up a syntran standard library, and then all of these functions that I'm implementing here today, I'm probably going to use them again in a later day of the advent of code problems. I'm going to call this index with an underscore. Whenever I have something that might conflict with a keyword, like str, I also have a type, where the type is str without an underscore. To avoid a clash between like a variable name and a keyword, I just put an underscore at the end of things. So I don't think I have an index keyword yet in syntran, but it's something that I might want to reserve later. So just for safety, I'm going to put that underscore there. So it's going to take a string, and it's going to take a substring. And again, we're going to return an index. I actually did this off stream. For the warm-up in 2020, I ended up implementing stream, so I did that before, but I've never implemented index before. So this might take me a little bit more debugging than it took me to do scan. Now we're not just looking for one character, we're going to look if the whole substring matches a part of the string. So instead of just like one character matching, I'm going to have to see if all of the characters are matching. So I'm going to name this variable allFound. Yeah. The basic loop structure is going to be similar. Only I have to be much more careful with overflows. So I don't want to like overflow past the end of the string, checking if like it matches the substring. So I less than length string minus the length of the substring plus 1. I hope that's right. This is going to be a tricky off by 1 error. So in the case where the substring is only 1 character long, then I want to go all the way up to the length of the substring, but like less than, not less than or equal. So if the length is 1, then this whole expression is 0. So I think that's what I want. Yeah, I hope that's correct. It makes sense the way I've described it, but I could be wrong. We'll find out. Now, we're going to flip this. We're going to immediately set all found equals true. And as soon as we find a character that doesn't match, we're going to break the inner loop. So while all found and j less than len substring, we're going to have an inner loop. And then if any one character doesn't match, we're going to set all found to false, and we're going to break out of the inner loop, but then like continue the outer loop. I also have to remember to increment I. So I plus equals 1, and then here j plus equals 1. Up here we're going to set j, initialize j to 0. Now, all found equals, it's going to be kind of similar to what we did here in scan. It's going to be string I equals substring j. All I changed for this line was the variable name, because now we don't have a set of characters, we have an ordered substring, where in scan, the order of the characters in set doesn't matter, because it's not really a string, it's a set of characters, but I'm just using a string as a type to contain that. But in index, the order of the characters does matter. So, is this right? I also want to like verify substring actually matches. So we're going to do string whatever. It's going to be string. It's going to start at I, and it's going to go up to I plus the length of the substring. Maybe that's off by 1. We'll find out. And this is only if it's found. So if, don't need a parenthesis, if all found, we're going to do this. Otherwise, we're just going to return -1 because we didn't find a matching substring. But if we did find it, we're going to return I minus 1. Again, we added I here after we found it, so then we have to undo that final add and subtract 1 here. But we want to do that before we print out the substring. And I want to save that in I. Because now this line is the return value if it's found, and then this line is the return value if it's not found. So this whole if-else block acts as like a split return statement, where we return one thing if it's found, and we return a different thing if it's not found. This is probably going to crash. I probably made some kind of mistake. I forgot the underscore at line 37. Line 37, I forgot this underscore. Yep, that crashed. But it did do 2 lines. I'm in part 2. And I'm not even calling this. What was... Okay, that's good. So I was calling part 1 instead of part 2. And this line does not have any digits. But part 1 is implemented in a way where we're expecting at least 1 digit, so of course part 1 crashed when we called it. I don't want to call part 1, I want to call part 2, and I'm going to comment out part 1 temporarily. And then we're going to put it back in once we get it working with the real input. And now I want to copy and paste part 1 and make this part 2. My cat really wants dinner, so in a few minutes I'm going to go feed her. Now instead of calling scan, I want to call index. And let's just find the first one for now. And then we're going to have to do index back in a minute. So I'm just going to comment all of that stuff out for now. Let's see what happens. We're in an infinite loop. Yeah, because what did I... First of all, this shouldn't go into an infinite loop. But I'm scanning for this substring, and that doesn't make any sense. So how do I break out of an infinite loop? First of all, I think I'm going to move this down so it's closer to part 2. Yeah, let's put it right above part 2. J, and then I increment J, I, and then I increment I. So how did I get into an infinite loop? Am I working with test input 2? 219823. So I got to the second line, and then what did it do? First of all, like, this is not the substring that I want to scan for, but regardless of what I'm indexing for, I shouldn't go into an infinite loop. So I want to fix this before I scan for the correct substring. Am I reading the file without going into an infinite loop? Yes, I can read the file. That's not the issue. This is like an invalid memory address. So I probably don't want to print this if I... Is it really an infinite loop? I don't know. This is some kind of undefined behavior, but like I is -1 here, I think. So I don't want to actually print that substring because it's an out-of-bound array reference, and that's dangerous. Like it might hang and look like an infinite loop, but I'm not sure that it is an infinite loop. Okay, -1. Well, -1 for the first one makes sense, but then it's still hanging. So what is going on there? Let's just echo these at the top of the index function. That seems okay. And then at what point do I get into an infinite loop? Oh. I is never, it's supposed to be plus equals. There should be like a type checker or something that catches that, but unfortunately that's not what type checking does, so I would need something else. But yeah, that was pretty dumb. If you didn't see what I did there, so I equals 0, and then I just have I plus 1. But this doesn't change the value of I. This would just like do some math and not assign it to anything. So maybe expression statements like this are a dangerous feature to have in a language. But what I meant to have is I plus equals 1. So this changes the value of I. This would be like the same thing as I equals I plus 1. But it's like a little syntactic sugar to do that as a shortcut. So that's what I meant to do. I messed up j too, so that should be j plus equals 1. Somehow, I did that right in scan, I think, but somehow I forgot to do that in index. Well, that was embarrassing. Okay, no more infinite loops. Now I think we can scan for the actual substrings that we're looking for. And this is going to be a pain because we're going to have to scan for every digit spelled out. So we're going to have an array of strings. By the way, Fortran is really hard to work with arrays of strings. Like, it's not a type that's built into the language. If you want arrays of strings in Fortran, it either has to have a weird restriction where every string is the same length, or you have to make like a user-defined struct for an array of strings. Syntran is a little bit better. You can have arrays of strings. So my nums are going to be, let's start with 0. 0, 1, 2, I hope I spell everything right. 3, 4, 5, 6, 7, 8, 9. That's it. So we're going to want to scan for any one of these strings. And we're going to have to keep track of if we find any of them, and if so, which one is the first one. So yeah, we're not going to do this. Let I min equals len string plus 1. I think len string would be safe, but let's just set it to plus 1 for extra safety. Statically allocated strings only, please, sir. This is, yeah, I don't know how to describe this. It's kind of a high-level interpreted language, so you should be able to do something like this in Python. I was playing. I missed some. That's all right. So I want to search for any one of these substrings in the input text. Rocket League. I've never played Rocket League. I've been playing a lot of Metal Gear Solid recently. Never played Rocket League, though. Yeah, so I want to iterate through this array. So for K. No, let's do J. It's sweaty, probably don't want to. For J in 0 through size nums 0, basically len is the length of a string, and then size is the size of an array. So use len for strings and size for arrays. So this will iterate through the array of numbers. And then I is the index of nums j. Now we have to check if we found it. So if I is positive or 0, we found one of these things. So if that's the case, if I is greater than or equal to 0, then imin, oh, this is good. So I define these in the right order. So the index of 0 in this array is 0. So I can easily convert from the string of the number to the number's value. And then like 3 is the third thing in this array. So if I put 0 at the end, this wouldn't work because then all of these values would be messed up compared to their place in the array. But if I have 0 at the end, this will work. So if I is 0, then imin equals the min of imin and I. So this keeps track of what the minimum position is. And then I also want to like set a value. So let's initialize it to -1. Let's say let val equals -1. And then if I don't find anything, this is still going to be -1, and I'll know that it's like uninitialized other than this value. So if I find something, then val is j, right? Because j is the index in this array of numbers. It's like if I find the text 4, j is going to be the integer 4, and then I save that value right there. So then I'm going to print val equals val. This is probably going to crash. Let's see what happens. Variable undeclared. So I need let. Okay, that ran. So what did we find? Is this the test input? This is really long. That's allegedly the test input. Why am I doing the same string a bunch of times? What just happened? So I have this line, that's the final line of, oh, I'm putting it inside the function. Yeah, let me comment these out. It's like, this is very verbose. That's more verbose than it needs to be. This is all the stuff I want to print. So let's see what that does. I think I need to feed my cat. Well, that didn't work. Didn't it? Oh, it was just printing the substring. Yeah, so my index function is not correct. Yeah, before I get this working, I think I need to feed my cat. So I will be back in a minute. We are so back. So my index function is not working at all. Let's see if we can at least find 2 on the first line. So how do I debug this efficiently? Let's just delete some text from the input. Let's do the first 2 lines. And that won't be insanely verbose. So what I want to do is I want to find the number 2 here, and I want to find the number 8 here. And then later we're also going to try to look for 2 and 3, but like at a minimum, I want to find those 2 numbers. And why am I not finding those? So that should be done in my index function. It should find a substring within a string, and that's not working. So I had a bunch of printing statements here. Let's re-enable those. Let's uncomment those. So what does that do? Not found, not found. Extra semicolon. There we go. So what does this do? Did I save that? Yeah, it's not finding anything. So like of course it doesn't find 0. 0 is not a substring of this, but it should find 2. Why does it not find 2? This is going to get pretty verbose because it's going to print like every number in nested while loops. But this is, I think this is the optimal way to look for substrings. And maybe I'm dumb, but I don't think there's any clever optimization you can do to search for a substring within a string. You kind of just have to brute force it. So 2. We should never increment I, because we should find 2 at the first index. So that would be I equals 0. I is the index of the string, and j is the index of the substring. So we should stop at I equals 0 and say we found the substring 2, and then break out of the loop at that point. But that's not happening. So why isn't that happening? Okay, yeah, so in scan, this was okay. We were always comparing to string I, but now I want to look at string I plus j, because we want to see if the t here matches, hold on, I scrolled a bunch. I should really open this up in a log file editor. So we want to see if the t here matches the t here, and if the w here matches the w there. So we want to like add something to I. And then finally, if the o matches the o. So I have to add to I. I can't just compare everything to I. So did that found something. This found an 8, see, because it printed the value 8. I think this might be working. Let's look at these a little more closely though. So 0 is not found, 1 is not found, 2 is found. Notice it doesn't print 2. And then 9 should also be found. So do we find 9? We're looking for 9. Yeah, I believe 9 is found. So, yeah, and then it gets the, why does that have the value 9? Yeah, I think my index function might be working, but I think my higher level function might not be working. So what values do we get? Yeah, that's not right. Oh, yeah. If I is greater than 0 and I don't want to do min like this, and I is less than I min, then we want to do this. And now in this case we don't need the min function. Min is just an intrinsic Fortran intrinsic function built into syntran. I don't have a lot of intrinsic functions, but I have that. But we don't even need it because we want to do the comparison here before we set the value. So will I get the correct values here? Okay, we got 2. 2 is the first number here, and then 8 is the first number here. I think that's right. Let's try it with the rest of the lines. We're not done yet because in this case we have like the integer 4 before any text numbers, if you know what I mean. And like we're not even halfway done because we have to do all of this from the end to the front too. So we have 2, 8, should be 1, 2, and then this one should be 4, but we haven't implemented that yet. So instead of 4, we have 9. So we're going to have to look for that in a separate loop, I guess. Then 1 and 6. So I think what we've implemented so far is correct. We just haven't implemented everything. So now we have to use the scan function that we used from part 1, and we have to do something similar to this. So yeah, we're going to say let j, let j. So here, j is a local variable within the scope of this block. So now that we're out of this for loop, we can redeclare another variable j. So that's why I can use let again on j. So let j equals scan string, and I think I don't want to hard code this stuff everywhere. So let me have something called digits. Do I want this to be like in my functions that I'm going to move somewhere else later? Because right now I have all of these functions in my day 1 source file, but I might reuse these functions in later days, so I'm going to move these out into a separate include file. The functions, at least, I don't know if I want to have my definition of digit. Guess I might as well. So let digit cares, yeah, equals 0, 1, all of that stuff. And then let's look for that. Okay, that's a little bit cleaner. Now we want to let j equals scan string for digit cares, and we want to keep track if it's the leftmost digit. So if j is greater than, so now j is doing something similar to what I did here. Let's reverse these. Let's call this I. If I is greater than 0 and I is less than I min, then we're going to do something like this, but I think we have to get the value differently. I min equals I. This is the last thing we're doing, so we don't actually need to set I min, but I will anyway, just in case I change my mind or just in case I'm dumb. So now value equals, we're going to have to parse this out of the substring because I is just the index of the thing. It's not like the actual digit. So we're going to have to parse I32 out of string I. Now that should be correct for scanning forward. And if this is correct, we're only halfway done because we have to do this and scan from the back to the front separately. So which one is different? I think only this one. This one and the last one are different. So that 4, now we have 4, and then 7, we have 7. I think that's right. Yeah, so we're halfway done. Now we have to scan from the back to the front, or index from the back to the front. So the same way that we made scan back from scan, we just like changed the direction that I is incrementing. Now we're going to make index back from index. So we're going to copy and paste this as two different functions because I'm not feeling very dry today. So index is going to be index back. No underscore, just all one word. Yeah, so I is going to start out as length -1. Or no, it's going to be the length of string minus the length of the substring. I think it's just that. Now, let me take a look at my index function, or my scan function, or scan back. So we started with I equals length -1. Now instead of 1, we have the length of the substring. And then we're going to do while I is greater than or equal to 0. Remember I had a bug at first, I just had I greater than equal to 0, but then I was like missing when the first character was a digit, so it has to be greater than or equal to 0. Now index back, it's going to be I is greater than or equal to 0. And then we're going to decrement I. Don't need that line, that was just for debugging. This stuff can be the same. This is the same whether we're indexing from the back or from the front. But this has to be +1. And I think that's it. So val, maybe I want to rename that. Not dry equals wet. I used to think about dry a lot, like don't repeat yourself, but then I saw a talk by Den Abramoff. I hope I'm pronouncing his name correctly. He made like React or something. He's a big developer. What did he do? Yeah, he made React. He has this talk on a little duplication is better than the wrong abstraction. Where did I see that? Was it like a TED Talk or what? Goodbye clean code. I think this might be it. Anyway, I'm not gonna like watch this video on this stream. Come on, Reddit, are you gonna load? Anyway, I can't find it, but he had a presentation where he talked about how, you know, sometimes you do all this work trying to like combine separate abstractions or combine separate things into one unified abstraction. But then you have like a bunch of like little if statements where it's like, if we're scanning from the back instead of the front, I'm going to add to this index instead of subtract from the index. But that's not always the right way to do things. Sometimes it's better to just duplicate things instead of making these incorrect abstractions. You can argue about that. Maybe this is not a good case to copy and paste this function, but I will. So I got that idea from Dan Abramoff, and now I'm using that to justify all my wet code. Yeah, so we have val. Val is from the front. So this is really val first. And now I also want val last. So let's copy and paste this. And so we're going to search for first and min. Our mins are going to become maxes. And index is going to be index back. We're going to check if it's greater than imax. And then scan is going to be scan back. Did I spell that right? Yeah, it's scan back. And now let's see, is that right? No. Well, that's easy. All I did was I used let when I shouldn't have used let at line 232. By the way, it takes a lot of work to make error messages that look good. Who cares, Perso project anyway. Yeah, this is throwaway code. I'm going to use this once for advent of code, and then I'm going to never use this again. So it doesn't need to be dry. Like, there are places where you should unify things and make your code dry, but this isn't it. Like, advent of code does not need to be clean code. Anyway, it takes a lot of work to make good error messages that say, like, which variable are we talking about? We have red text so that this text catches your eye, and then it tells you the line number and the column number and the source code name, file name, and then it shows you the line number again, and then it shows you the line of text, and it underlines and points to the character which is wrong, and it says variable already declared. This stuff takes a lot of work. And I have this implemented for some error messages, but like half of my error messages are not this nice. So, damn, wait, I didn't even realize that's all you. Yeah. This is based on Rust. Rust error messages kind of look like this. They have like cyan text right here for the line number. So I took a lot of inspiration from Rust. But yeah, if you've ever used a compiler where like the error messages are like not that easy to read, that's why, because like this stuff is a lot of work. Anyway, line 232, just get rid of let. Now let's see, is this stuff right? We should get 2 and 9. 2, 9, 8, 3, 1, 3. Yeah, that seems correct. 2, 4, 4, 2. See, this is different because now we don't have text. We basically ignore all of the text because there are actual digits at the beginning and end. So this is 4 and 2. We have 1, 4, 7, 6. I think that's right. Now we have to get the values. Cough, cough, GLSL. A T slipped in. Oh, coughed. But GL, oh, the shader language. Yeah, I've only messed with shader language very minimally. So they have bad error messages. I don't know if I've even looked at them very much. Okay, now we have val first and val last, and these are actually integers. These are not strings. So we have to turn them into strings, concatenate them, and then parse that back into an integer. Fortunately, I have intrinsics for that. You're not going to have to watch me implement that in syntran too. I can delete all of this stuff from part 1. So sum, yeah, actually here it is. Sum plus equals parse. Yeah, why not? Let's have a temporary variable. So let digits equals, we're going to concatenate strings. And there are a couple different ways you can do this. I could do string val first plus string val last. I could convert this one to a string and convert this one to a string separately and then concatenate them. Or the string function is variadic, so I can just do it in one call like that, and that should be the same thing. Let's see, do these add up correctly? 281, is that right for the test input? 281, okay, now we just have to run it on the real input and pray that it works. So let's go back to the real input. This will select, no, I want 1 as the real input. So 1. IDK, maybe there's a way to get more detailed errors with OpenGL calls, but it just errors wildly with little context by default. I can kind of understand that because a lot of the time with shader language, don't you have like shader source code as a string inside of C++ or inside of some other language? So that's like a whole nother level of interpretation where you have one language embedded as a string inside of another language. That's not always the case though, because I think sometimes you have like a separate GLSL source file. Let's see, is that right? Oh, thank God. That took way longer than I wanted day 1 to take. I was hoping I would get something easy on day 1, but I had to like do a lot of prerequisite work in syntran first. Yeah, you pass the string to a function, but I just read mine from a file. Yeah. Anyway, I've not had the pleasure of having to deal with GLSL too much. Yeah, so that's day 1. It looks like day 2 is going to unlock in about 3.5 hours, but I'm not going to do it tonight. I'll probably stream sometime tomorrow morning. So I will end this stream soon, but I want to commit the code that I wrote. And I also want to get part 1 running, and I want to get some of this debug logging turned off so that it just prints the answer instead of like everything leading up to the answer. So it's actually quite nice considering I've seen some ungodly Vulkan code bases that can just explode the same. I haven't used Vulkan at all. I have a little bit of experience with GLSL and 0 with Vulkan. IDK I'm writing in Kotlin with binding, so it's easier. I want to do part 1 and part 2. Do I want to have some text in here? So, yeah, say like, warning. This test input crashes part 1. Because like you don't find digits, and then you end up with like an out of bounds array reference. So be careful if you're playing with this code. With the real input, both parts should run. I did some CPP OpenGL, but I'm just not that guy. Yeah, that's what I did. I started to make a Tetris game in C++ with OpenGL, and then I never finished it. But that's like, that's pretty much all of the GLSL experience that I have. Oh, why is that crashing now? Oh, I think I forgot to close a file. Yeah, I opened my files, but I never closed them. And that's not good because here we open in part 1, and then we open again in part 2 without closing. So this is, I should have a nice error message here. This is one of the errors. It's a runtime error, and I really don't have any good runtime error handling. So you just get a random Fortran stack trace. But I need to do that in the template too. I opened, but I never closed. So close F. So I want that in the template. And then I want it here too. I definitely need to close at the end of part 1. Closing at the end of part 2 is not as important because then the program is finished. And it doesn't matter if I close the file or not. If you're closing files that you're writing, that might be more important because I don't know if my language will flush the buffers. You might like not write everything that you tried to write if you forget to close. But for reading, it's not really important if your program is ending anyway. Okay, there's a bunch of stuff. It's still printing more than I want to print. By the way, how long did that take? This is not the fastest language. I have lots of things to optimize. Every time I pass a string to a function, the string gets copied, I think. I'm not even 100% sure. But this is by no means the most performant language. What the hell is still printing? I think, oh, it's these functions. These functions end with implicit prints. We can suppress this by working around it like this. Okay, I think that should, yeah, this is weird. This is not something you should have to do, but work in progress language. 37. Is it already declared? Aren't they in separate scopes? Okay, I forgot how scoping works in my own language. Apparently, like the else clause shares a scope with the if clause. I don't know. I don't know if I like that, but apparently that's how this works. Yeah, maybe we should just set it outside of the if, and then we don't need the else clause at all. Yeah, optimization worked forever. The thing is, I'm just not going to optimize it. It's a toy language, so I'll never do it, and I don't care if it's slow. Semicolon. So I'm going to have the same error in a bunch of places. Line 61. I think we'll have it in a couple more places. Unexpected token, line 34. What did I do here? Equals. Lol. Is that part 2 or part 1? Okay, I guess that's both. And then part 2 really takes a while to run because we're doing a whole bunch of inefficient string parsing. I think maybe I can optimize something right here. So this took 3 seconds. Let's see how consistent that was. I don't know if it takes 3 seconds every time. There's probably some variation. 3.3, 3.4, 3.3-ish. So inside this loop, we read a line of the file, and then we assign this array. But this array is not changing inside the loop. So I think I'm wasting a lot of time just like resetting this array when it doesn't need to be done. When in fact, I should be able to set this outside of the loop. And I don't know if this is actually going to make it faster, but it might. So let's see what that does. I think it's just as slow. Yeah, that didn't do anything. Yeah, I thought it might. Probably just the index function is probably taking a lot of time to like copy strings in as arguments. I don't know what to do to optimize that. That would take more serious development of the syntran language, but I just want to get the advent of code done this month. Are these answers right? So I had 53194 and 54249. Yep, those answers are right. So I think I'm ready to commit and then wrap up the stream for tonight. So we have the template, which we're going to copy for day 2 tomorrow and every day thereafter. We have the inputs and the test inputs, and then we have our actual syntran code that solves the problem. I think that's it. Let's make sure that that pushed. So this is like the bare repository with just GitHub default files. And now we have our solution, and this is on GitHub. If you want to find this in my bio on Twitch, I should have a link to my website, and then my website will link to my GitHub. So once you get there, you should be able to find AOC syntran in my recent repositories. If you're watching this on YouTube after the fact, I should just have a link to this in the description, so check that out below the video. And yeah, there's our code. We implemented a lot of stuff, which is going to be like a shared utility, which I will probably get to reuse in later Advent of Code days. So like scan back to find a set of characters in a string, and then also index and index back to find a substring within a string. And then beyond that, we have the actual solutions to part 1 and where's part 2? Here's part 2. Yeah, so off stream I might like break this up into separate include files, or maybe I'll just do that on stream tomorrow. Yeah, again, this was a little bit more work than I thought I was going to have to do for day 1, because like I don't have these basic string processing functions built into syntran. These things would probably be built into most other languages. Yeah, we'll see what we get on day 2. I think that's it for tonight, and I will catch you next time. Bye.